1.5 Functions and Logarithms. A function f of x is 1-to-1 on domain D if f of a is not equal to f of b for a not equal to b. An inverse function is reversing a 1-to-1 function an identity function results from composing a function and its inverse function finding inverses. So this is going to be for writing f to the negative 1 as a function of x. So first we hold on, I think I have these backwards. Oh, never mind. Just went written weird. Solve the equation y equals f of x for x in terms of y. Interchange x and y in the resulting formula will be y equals f to the negative 1 of x. So this is actually a little different than how we do it. We normally swap x and y first, then solve for y. They're saying basically solve for x and then swap x and y, which is the same thing, it's just a different way. So if you're used to our other method, I'm just going to do this. Or swap x and y, solve for y. Since that's what I'm used to, that's what I would be more inclined to do, but if for some reason that method confuses you, now you have another one. All right, next is logarithmic functions. So y is equal to log base a of x is the inverse of base a exponential function y equals a to the x. So So that's just saying those are opposites. So we're doing exponentials in the last section. Now we're doing logs. And just a notation reminder. Log base e of x, we would write as the ln of x. Those are the same thing. And log base 10 of x, we call the common log, which is just log of x. Some inverse properties for a to the x and log base a of x. So for base a, which would just be any number, any number greater than 1, a to the log base a of x is equal to x. So if the base and the log base are the same, then it's just equal to x. And similarly, log base a of a to the x, those cancel each other, and that is also equal to x. And that's for a greater than 1 or x greater than 0. And if we had base e instead, so for the natural log, it would be e to the ln of x. And because ln is base e, those cancel and leave us with x. We also have ln of e to the x, so that's e to the x basically. That's also just x for x greater than 0. All right, and lastly, some properties of logs. So for any real numbers, x greater than 0 and y greater than 0, we have a product rule, which says the log of a product is equal to the sum of the logs. Okay, I'm writing it out in symbols, but that's what it means. Quotient rule, log base a of x over y. So the log of a quotient is equal to the difference of logs. It's always top minus bottom. So log base a of x minus log base a of y. Then we have our power rule. Log base a of x to the y is equal to y log base a of x. So if you got a power, throw it out front. And the last thing is the change of base formula. I guess it's not really a property, but kind of just throw it under there. Change of base formula, if you have log base a of x and you want a different base, like a common or a natural, we just rewrite it as whatever base we want. So in this case, ln of x over ln of a. Could have also done log x over log a if you wanted common log instead. And just a reminder, since it's been a while since we did it, for a function to be 1-to-1, it has to pass the horizontal line test. So if it intersects in more than 2 places, it's not 1-to-1. Function is vertical line, 1-to-1 is horizontal.